we want to look at a sugar is packaged in a 5-pound bag. An inspector suspects that the bags may not contain 5 pounds. A sample of 50 bags produced a mean of 4.6 pounds and a standard deviation of 0.7. Is there enough evidence that the bags do not contain 5 pounds as stated? At alpha equals 0.05. Also, find the 95% confidence interval for the true mean. So they've just asked you to test that the bags do not contain 5 pounds of sugar, and they've asked you for the interval. Either way I do this, I still need to identify. We still need to know what they gave me. So let's figure out what they gave me. What can we identify?
N is 50.
N is 50.
Your standard deviation, which is S is
0.7. All right. My sample mean. Which one's my sample mean?
4.6.
4.6. And which one's my mu? 5. The 5 pounds that are supposed to be in each bag. And then we've got our alpha. And we have our confidence level. Now, I need a hypothesis because I am testing something. So let's make our null and our alternative. The null hypothesis is what? Mu is equal to 5. Oops, not 55. And then what's the alternative? Does not equal, because we don't know whether it contains more or less than 5 pounds. We're just saying it doesn't contain 5 pounds. Which also means that if that's what we're saying, that's where the claim lies. Now I could go through and find a test statistic and a p-value and solve it that way. But I also know they're telling me I have to build an interval. So let's build a confidence interval and use that to test our claim. So let's build, we have one set of information, so one sample. We have S instead of sigma, so what kind of interval am I building? Is it a Z interval or a T interval? T. So I'm going to go to my stats area and over to test and make sure I go down, to the interval section and pick the T interval. Now we have statistics instead of data. And we know that our x bar is 4.6. Our standard deviation is 0.7. And our sample is 50. And we want a 95% confidence interval, so 0.95 for the C level. And let's see what we get. All right, so I've got 0.4011 for the lower. And my upper is 4.7989. Does everyone agree? Yeah? All right. So I built the interval they asked for, and I have my hypothesis. How can I make a decision about my hypothesis based on this interval? What is the interval supposed to contain? The true mean. What are we saying our true mean is right now? 5. Is 5 in my interval? So, since 5 is outside the interval, what did we talk about? Rejecting. If it's outside, we're going to reject. And I'm just going to add a note that because 5 is outside the interval, so if we're rejecting, what does that mean in terms of my sentence?
We're 95%.
So we could talk about the interval, that we're 95% confident The true means inside, except what happened with this one? It's that 5% that it's not inside. So I actually want to talk about the conclusion for the hypothesis. Is there evidence or is there not evidence? There is insufficient evidence.
It's so hard to determine which one to use. Or do you know because you're rejecting
Since I'm rejecting,
the HO? Then it's all
oh wait, I don't know what I'm doing. There is evidence. We reject it. Yeah. I'm thinking the opposite. I don't know.
So
why. There is evidence because we rejected the null and we are accepting the alternative.
Okay.
So we're supporting that claim that's in the alternative. So we're going to support the claim that the mean number of pounds of sugar in each bag is not 5 pounds. So we're saying it does not contain 5 pounds. Now, the nice thing that we can see from this is since we have an interval, what could we say about how much it does contain?
between 4.4 and 4.7.
It is containing 4.4 and 4.7 pounds on average. So it's actually always lower than what they said. So we can kind of add that in as a separate comment that the bags of sugar contain 4.4, and I guess if I'm rounding, it'd be 4.8 pounds 95% of the time. At least that's what our interval is telling us based on our sample. So it's kind of nice because when we do reject the null hypothesis, we can kind of get more information by having the interval and say what is going on based on our sample. But I didn't have to actually run both processes to do both. I can get the interval and do the hypothesis test with just my interval. So it's kind of nice. Questions on that?